So hello everyone, and thanks so much for attending today's webinar on real-time monitoring of shipping emissions, a case study from the Balearic Islands of Spain. My name is Masse, and I'm the director of Apex Instruments Ambient Air Division. And today's case study will talk about a project that was conducted by our colleagues, or in support of our colleagues, Kunik Technologies, who's the manufacturer of the multi-pollutant air sensor system that we'll be discussing today. Apex is the distributor for Kunik, as well as the North American Service Center for Kunik. So as many of you all are probably aware, if you've worked in the ports industry for a while, about 80% of traded goods are transported via the seas. And this contributes to at least 3% of global greenhouse gas emissions and produces pollutants like NOx, SOx, carbon monoxide, and particulate matter. I'm sure that many of us are interested in seeing the reduction of pollution and reduction of health impacts associated from the shipping activities that are necessary, while also meeting regulatory compliance. So the project I'm going to be discussing today started in 2016 in the Balearic Islands. The Port Authority there launched the project with the goal of analyzing emissions from their different ports. This project involved the collaboration of a local university. They also put out a public tender to acquire the air monitoring equipment. They worked with an environmental modeling company and a different company to help develop a public-facing website and conduct maintenance of that public interface. Now, the Port Authority's motivations for the project were to overall reduce air pollution, which is not all that unique, but they wanted to really understand how they can make the air cleaner in their port cities. So these port cities are big tourist destinations in Spain, so they wanted to make sure it's an attractive location for tourists while also protecting workers and residents who live there. They were specifically interested in investigating episodes related to high CO2 events, and they wanted to be able to comply with and achieve their own ESG policies set forth, as well as gaining a better understanding of how their port activities impacted air pollution. So the Balearic Islands are just off the eastern coast of Spain in the Mediterranean Sea. The project they conducted has been a multi-year project. It's actually still ongoing, and it's involved 5 different port cities across the Balearic Islands. There have been at least 25 different sites identified across these 5 ports where multi-pollutant gas sensors have been installed. And yeah, just keep in mind that these results are still ongoing, so no final conclusions have been drawn yet, aside from that the Port Authority plans to continue practicing air monitoring work after the conclusion of the project. So before getting into the details of this case study, I wanted to just provide you all a little bit of background information about Apex and our division, if you're not familiar. So Apex Instruments has been around since the late 80s, and we're based in North Carolina. We're emissions experts and have multiple different divisions related to source testing and complementary business segments. So we have a line dedicated to reference analyzers and heated sample lines. We have a division that works on custom mobile laboratories or trailers. We also have a training division, and then the Ambient Air division is our newest division, which I'm leading. Now, within the Ambient Air division, we have 2 primary functions. We are operating as distributors for 2 different product lines. The first is the multi-pollutant sensor system on the left, which is manufactured by Kunik Technologies that we're going to be discussing in detail today. And then our newest product is the field deployable micro-scale gas chromatograph for speciated VOC detection at places like oil and gas refineries or petrochemical plants. So the Kunik system is really a professional grade sensor-based air quality monitoring system that provides highly accurate data. It's capable of detecting multiple pollutants simultaneously, making it a more cost-effective solution compared to reference grade equipment. It also helps to enhance your spatial resolution of an area because you can purchase and spread out a lot more sensor systems due to the lower cost. And we're ongoing getting additional certifications to help highlight the data accuracy of these systems. So our product really helps to fill a void between lower cost air quality sensors and reference grade equipment. This slide just shows you an overview of the different QNEC products. So we have two different multi-pollutant sensor systems. The one on the far left can analyze up to 5 gases simultaneously along with PM. The other unit can monitor 2 gases simultaneously with PM. And then the whole premise of these systems is that they're highly customizable, where you can select from a wide range of different pollutants. These are the individual gas cartridges here. Those plug right into the system, and then everything's monitored by the cloud platform. So for the case study in the Balearic Islands, the Air Pro system was used, and it was used with the following sensor setup. So SO2, NO, NO2, CO, ozone, and the second phase of the project, VOCs, along with PM. And what's also nice about these systems is that they have connectors, additional connectors on the lower part of this system where you can connect meteorological sensors. So for this project, anemometers were connected along with rain gauges, and in some locations, noise sensors as well. Now, this slide shows a couple of screenshots of the cloud-based platform. So all of these systems used in the case study today use cellular communication option to communicate with the cloud, where data is uploaded, and you can maintain and oversee the health and operation of the different sensor systems. So you can generate views for heat maps or pollution hotspots. You can look into leak detection related to certain gases. You can model the PM size distribution or conduct multi-parametric analyses. You can also develop customized reports that are automatically sent out to a listserv if that's desired. And then this slide just quickly shows a number of the third-party evaluations and certifications that have been achieved. So AQSpec in the US has evaluated these systems, and they're actually about to release another report on the most recent model. AirLab in France has released a report that I'm happy to share with you all. We've worked with the EPA to evaluate the use of the systems, along with a number of other certifications that have been achieved with different organizations. So pivoting back to the case study, the pilot project began in 2016, where a local university was running the technical portion of the study. And initially they were using non-QNEC sensors for the first attempt at understanding the port's impact on air quality. The purpose of this pilot was really to evaluate the use of the sensors and the design of the monitoring network to help as an aid for decision-making for the ports. To do this, they first deployed 8 real-time air quality measurement points in just one port, in the port of Palma. And the big takeaway, what they learned from this pilot study, was that the sensor network was very helpful in monitoring environmental variables in the port and to help make data-driven decisions. Their other big takeaway was they didn't really like these particular sensors that they were working with initially. So that led to phase 1 of the project, where in 2018, a sensor product comparison study was conducted with the sensor system that was used in the pilot study compared to the QNEC product and a reference station that was in Mallorca, Spain. So the plot that you're seeing here at the top compares the performance of the QNX system, the reference station, and the initial sensor system. And you're probably noticing that you really can't see the reference station data very well because it's overlaid by the QNX system. So there was high correlation in the performance of the QNX system to the reference station. So this comparison study, really helps to identify the technical specifications that would be needed for the project moving forward. So before the phase 1 project really started in 2019, there was a public tender put out. In that process, QNX was selected as the winner of that tender. In this phase 1 portion of the study, QNX provided 25 different, there were 25 different locations selected, and QNX provided 50 of their Air V2 devices. So this is a prior model to what you saw in my earlier slides. And they used the CO, NO, NO2, ozone, SO2, and PM sensors, along with an anemometer, a rain gauge, and a noise level sensor. So these 25 different locations were spread out across the 5 port cities, and the number of sensor systems or points set up at each port was determined based on how busy that port was. So this slide here from the phase 1 portion of the study shows data that was collected and tracked for air quality impacts. So on the left-hand side, this was the public-facing website that was developed. So the data here was used to detect different impacts from the ports and to help analyze those impacts and determine if potential emission sources could be identified. And then on the right-hand side, this is actually part of the public-facing website platform that was developed as part of this study. And you can actually still go to that website here underneath for the Balearic Islands port, and you can look up different nodes that are still being used and see the real-time air quality index data. So one of the other things that was found out during this phase 1 of the project was how you could correlate different port activities to specific emission events. So I'd mentioned earlier that being able to identify CO2 emission event or SO2 emission events was of key interest to the Port Authority here. So the screenshot on the left is actually from the QNX Cloud software. It's showing you like a leak detection view of SO2, and they were able to correlate the ferry that operates, this dotted line here, the ferry, and different spikes in SO2 events. So in 2021, phase 2 of the study began after a successful 2 years of the phase 1 project, and many lessons had been learned. So in phase 2, they set out to pick some different locations for the port, for the sensor position at the different ports. They also used new devices for phase 2. So by this point, QNX had rolled out their Air Pro system, which is the model that we currently sell and that you saw in the earlier slides. And so they were able to set up 25 different devices for this phase 2, where again, each of the devices can simultaneously analyze 5 gases and PM. They also added some new parameters. So they incorporated a total VOC sensor to each of the points. They added more rain gauges across the ports, and they added an anemometer to each point. They also integrated the monitoring system and simulation tools into a third party's platform called Smart Environmental Platform. All right, so this slide has a video capture from the QNX Cloud that shows different variations in PM10 measurements over a 24-hour span in Palma, Spain. And this is the busiest port in the Balearic Islands. So they had 8 different AirPro systems set up in use. Many of the port cities have been placing new air quality requirements and operational requirements on ships while they're in their ports or waiting to dock. And with the use of this air quality monitoring network, you can identify specific ships that maybe aren't complying with the local protocols and regulations, if they're supposed to be plugged into shore power or if they're supposed to be operating differently. So from the time-lapse video, you're able to see where specific hotspots occurred and go and communicate with the ships if needed. So this screenshot is looking at pollution hotspots for nitric oxide. We also had combined an anemometer here, so you're able to see that the worst NO emissions are actually coming from this small channel off to the side of this particular sensor. Unsure what specifically was going on with this high reading, if it was shipping related or not, but being able to identify the source or general source of where the emission's coming from allows the port to make decisions about how to react. So again, this project is ongoing. It's actually set to conclude in 2026. The public-facing website is showing real-time data for the different sensor systems and their networks, so you can go check that out if you're ever interested. Big takeaways so far have been that the Port Authority has been able to get really a comprehensive understanding of emissions generated by port activities. They understand the cause and effect a lot better now for their different port cities. They can detect specific pollutants and understand potential sources for those specific pollutants. They've been able to identify SO2 emission events and even tie it to specific ships that might be responsible for it. And again, by combining this AirPro data with shipping schedules, you can identify how, when, where specific ships might be polluting and make recommendations or adjust procedures or regulations for improved idling or docking procedures. So all of this data really has helped to empower the Balearic Islands Port Authority to set up and enforce different emission reduction goals. So hopefully you might be able to see how this could apply to some of the facilities that you work with. I just quickly wanted to also mention a couple of other ports around the world that are using these Kunik multi-pollutant air monitoring systems. So this is the port of Cotonou in Benin. It's a large port that's located near a significant population base and also alongside a popular beach. This port is known for handling different bulk carriers and container ships. And the sensors here were set up to help identify the impacts from emissions. They wanted to be able to detect high gas concentration events, improve the outcome of worker health safety, and comply with their local environmental standards. So this particular screenshot here, I always kind of liken to Battleship, where you can see the different ships here highlighted in yellow and the different sensors set up around the port. And here they were interested in identifying which specific ships were responsible for increased exposure to different pollutants. This slide just highlights the activities at the Port of Dunkirk in France. So they set up a perimeter network of air quality sensors. They are known for handling a lot of heavy bulk and containers. They wanted to set up air quality monitoring index here, so they have the ability to display that with a public-facing widget. They wanted to understand gas control of the different processes that are used throughout the day and identify correlation in air quality with meteorological data and help to put in place plans to mitigate air pollution for the nearby surrounding communities. And finally, the last port that I'll just highlight is the port of Zeebrugge in Belgium. Here they're interested in ensuring that particulate matter limits were achieved by the port activities, so set under the compliance target. They also were investigating different leak detection events. They were modeling dispersion of different pollutants and wanted to work on forecasting efforts to help figure out which communities or areas might be impacted by high PM or high gas pollution events. So with that, hopefully the case study here was able to help show you how having an air quality sensor network in a port might be of use for you, or you could perhaps make a leap toward how this might be a useful network to have for any sort of industrial site. Many cities and ports here are interested in protecting the health and well-being of employees, their residents, and potentially tourists. So having more information to help make better choices can allow you to do this, and really to enable your plans and efforts to reduce emissions. So with that, I would like to just thank you for your attention and leave you with wondering how these sensors might work for your facility. So if you have any follow-up questions about the performance of the system or about the case study, happy to answer questions for the remainder of our time here, or connect offline and schedule a one-on-one meeting if you want to discuss a project in more detail. So thank you. Do we have any questions? You can just drop them in the chat. I see some questions rolling in. Excellent. So there's a question about, do other ports around the globe have air monitoring for ships? I'm wondering if you mean like air monitoring requirements for ships, or are they using any type of air monitoring system? I have found it varies a lot from the ports that I've talked to so far. Some have sensor systems set up, some don't have much set up. It seems like some of the ports in Europe are a bit more ahead than some of the ports in the US, but I certainly haven't gotten to speak to everyone yet. Yeah, it seems to vary a lot. I went to a conference not too long ago that was focused on environmental impacts at ports, and each port was kind of operating independently, similar to how some of the states like to operate in the US. So I think providing good examples of how you can effectively and fairly easily monitor your air quality emissions leads for a good example for other ports to follow. Any other questions? Well, I'll be following up with you guys and share a copy of the slide deck here today, and would be happy to answer any other technical specification questions or think through how these sensor systems might be useful for a future project. Again, my email's here, so feel free to reach out sooner if you have any questions. And thanks so much for your time today. Have a good rest of the week. Bye.